Sure, honey, and I found Rosie and I brought her back home this day.
In order for robots to assist humans in daily activities, both at home and at work, current state-of-the-art approaches pre-program various social behavior into robots. Drawing inspiration by mainly mimicking important human gestures, examples of these behaviors are gaze capture, pointing, wave hello, or beckon for assistance. I would like to find out how these gestures can be learned. More specifically, is it possible for some of them to arise naturally through a robot's interaction with humans without explicit programming? First and foremost, given different physical appearance, morphology, and capability of robots, simply mimicking human gestures may not be the most efficient way for robots to communicate with humans. Secondly, learning potentially enables the robot's interaction behavior to change over time and adapt to the preference of the user. We will see more benefits later in this presentation. To achieve these goals, my work borrows inspirations from psychology literature. As the famous psychologist Vygotsky observed, pointing is nothing more than an unsuccessful attempt to grasp something. In this case, pointing is a gesture. Grasping, on the other hand, is a manipulation behavior. To me, this suggests a connection between manual behavior and communicative gesture. In fact, in the presence of the caregiver, acting out manipulation behavior, even if unsuccessful, portrays the intentions of the child, and it becomes a gesture when it is recognized by the caregiver. I hypothesize that this idea can be applied to robotics to enable robots to learn communicative actions that are both grounded and are adaptive. To study this problem, I use a bimanual humanoid robot platform named Dexter. With the control-basis learning framework developed in our lab, through stages of learning, Dexter was able to first learn simple programs such as the search track program to find and track interesting objects. Later, it also learns a more complicated reach grab program that enables it to both find an object and touch the object to get more reward. After which, we challenge Dexter even further, and thus it's able to learn to embellish its reach grab program to handle cases where objects are placed in different areas of the table, as well as objects of different sizes. The research questions I'm interested in are: can these actions form the basis for conveying intentions? Can a robot autonomously learn this through natural interaction with humans? Can this approach handle incremental learning, where more manipulation actions becomes available in later stages? To address these questions, the following experiments are devised. We use the same setup as in the previous manual skill learning experiment, and simply further the challenge of the robot by moving the object out of its reachable area. And a benevolent human is brought into the scene where he interacts with the robot for a number of rounds. In each round, several objects selected from this pile of objects are placed on the table. The robot randomly picks an object of desire at the beginning of each round. I want to see if the learning framework will enable the robot to learn sequences of actions that are useful for soliciting assistance from the human, even though these actions may originally arise as a result of manual skill learning. To facilitate the learning process, we employ the previously used stage learning strategy by first limiting the robot's resources and only allow it to explore actions associated with its head. In the second stage, this constraint is lifted, and the robot is allowed to freely use both its head and its arms to explore. 16 subjects of convenience are recruited for the study. 7 of them have computer science background. The remaining 9 are novices drawn from different backgrounds, ranging from art design to astronomy to polymer science to accounting. Amongst the subjects, we also have a good mix of undergrads, graduate students, and working professionals. The subjects were told to interact with the robot for a number of rounds. The robot will randomly pick an object of desire at the beginning of each round. They should simply observe and step in and help when necessary.